Good day, everybody. Hello to our online audience and welcome back. We had spring break here at Yale the last 2 weeks. We're welcome to have you all back and pleased to have one of our esteemed faculty from the School of Environment with us today, Dr. Narasimha Rao, who's Associate Professor of Energy Systems. And in addition to that, a senior research scholar at the International Institute for Applied Systems Analysis in Vienna, a pedigree. I was there for a while, a long time ago, and we just discovered that. Anyway, really thrilled to have him here speaking to us about energy justice as global justice. Please welcome Professor Rao.
Hi, everybody. Welcome back from spring break. Nice to see some familiar faces. So yeah, I'm going to talk about energy justice as global justice. I know a lot of you have been in this class exposed to energy justice from perhaps a US perspective, a community perspective. And I have two goals with this class today. The first goal is to provide an overview, especially for those who haven't been exposed very much to global energy poverty issues, provide an overview of the state of energy poverty around the world and what it means for energy justice. And then I want to actually get us to think about, when do these energy justice issues rise to a global justice problem? When do we think about it as a global justice problem? And I'm going to be talking about climate change in that context. So let me give you a bit of a guide for what I'll be doing. There's so many different perspectives in energy justice. I know in your readings in the first class, you looked at that. Broadly speaking, we can think of energy justice in a positive way, where we're just understanding the state of energy inequality around the world. Yeah, it's a little bit more of a characterization of systemic injustices in terms of particular groups of people either having a persistent state of energy poverty or people bearing persistent brunt of the side effects of the energy system, be it pollution or something else. So that's kind of a characterization of an energy inequality. But then there's another umbrella, which is a more normative umbrella. It's thinking of energy justice as a set of claims people can have, right? And that's the perspective I want to take today. A little bit more fundamental, because I know this field is strewn with very, let's call it, flexible use of the term, maybe even sloppy, but it's not really clear what we mean by it. We could be talking about procedural issues or outcomes and goals. So I want to make clear my perspective is normative and fundamental. And I'm thinking about fundamental claims that people have, an entitlement people have to energy services. What that really means, and I'm going to draw on a couple of examples in the literature on definitions. So energy justice aims to provide all individuals across all areas with safe, affordable, and sustainable energy. So this echoes a lot the Sustainable Development Goal 7, SDG 7, right? So we'll be talking a lot about that. Another view looks similar. Energy justice is ensuring that every person has a right to the level of energy required to attain a minimum level of well-being. And this is hinting at, to me, a much more realistic and important view that energy is so fundamental and instrumental, not just at the household level, but economy-wide to provide a whole range of services. And therefore, when we think about providing people with well-being, we have to think not just about providing people with connections and basic energy services in the household. So when we think more broadly about that, then we think about energy justice not just as having energy services in the home, which tends to be a lot of the focus when we talk about energy justice. And the second issue is broadening beyond who has the entitlement to who has a duty to provide, right? There is no sense in making a claim unless there's someone who's going to have to fulfill that claim. So when does that arise? Today, we don't have any formal such structures or institutions in place, but it's just to think along those lines, right? What do we see in the world in terms of SDG 7? Why is that an international problem, right? Why is it a UN goal? And then I want to talk about perhaps an even stronger claim that can be made because of climate change and because of this broad importance of energy for human development in general, why there may be a place for energy justice in climate justice, global climate justice. Okay, so let me provide you my frame for why energy is so important. This is very fundamental. Some of you who've been in ESA before have seen this, not this particular slide, but the idea that energy is so fundamental for human life, right? Any activity, any human activity requires energy. It's not just the sustenance of life, but the transformation of materials. For any material that we use in our lives, technology that we use has to use energy. And energy that we find in nature, the forms that we find are not useful to us. We need to transform them to forms that we can use. You know, whether we are talking about energy extraction and delivery, we need to set up an entire physical system to deliver energy services to people. And that's costly. It depends upon having fuel endowments. And so it's quite an endeavor. And that's why we need to understand when the provision of those energy services is an encumbrance, or when it's a serious challenge that has to be met more broadly. So with that, we can think about the importance of energy from a very micro scale, like I said, which is connections, all the way on the left of this arrow. And that's where we are with SDG 7. The starting point of thinking about this as a global problem is simply, let's get everyone connection to clean, affordable energy. Okay, so we think about connections, but we can think about connections in terms of providing services, right? You can provide a person with an electricity connection, but they'll not use electricity because it's too expensive or it's not even available all the time. So we may think about reliable service and affordable service from those connections. Unless you have that, people can't enjoy the services. Okay, so that's one step beyond just the current definition of energy access. But then think about the customer side. If they are going to enjoy energy services, they need appliances. You need a television, you need an air conditioner if you want to cool your home, not just electricity. You need a stove, not just the fuel supply, right? And you may not be able to afford the appliances for the energy services. And this is not even in the gamut of indicators when we talk about energy access indicators, right? So then that's the third bullet. It's energy services from reliable, affordable connections that requires appliances as well as the fuel carriers, right? So it's not enough to just have your sort of rooftop PV and battery system. What are you going to run with it, right? Okay, that's the household level. But like I mentioned to you, every economic activity requires energy. And if you think about what people need for basic well-being, whether it's healthcare, education, transportation, all of that indirectly requires energy. There are countries in sub-Saharan Africa today, the poorest countries, where over 90% of schools do not have electricity, right? We need to talk about energy services to those fundamental services that are delivered to people. They're not energy services, but they depend on energy, right? And so therefore, those indirect energy services have to be accounted for. And that's a large part of my research. So I'll be talking a little bit about how we think about energy for decent living, which raises the question of, are there energy justice claims by countries? You know, we need a minimum amount of energy to deliver development to our people, right? And then the final view is actually thinking about reducing energy. This is more of a problem among, let's say, the affluent around the world. It's, are we consuming too much? We have so much excess consumption. Can we sustain this level of consumption forever for future generations, given the fact that they have negative effects on climate change and other environmental impacts? And so there is this whole literature on energy sobriety, energy sufficiency, right? I'm not going to touch on that, but that's part of the inquiry about energy justice. It actually goes to not just raising people's energy levels, but bringing them down too, right? So with that in mind as a frame, this is what I'd like to do today. I'll start with energy access at the household level. I want to talk about cooking and then electricity access. And I want to be very provocative and put forth to you some really major challenges, because this sector is viewed as a big success story in the last decade or so. And I want to put a reality check on it. And by the way, if you're interested in these topics, I go deeply into them in my spring seminar, Energy and Development, which I'm currently teaching. None of you are in it, obviously, but I will be teaching that next spring as well. And then I want to talk about this energy for decent living at a national level in the second stage of the class today. To give you context as to how new this global view of energy access or it being a global imperative. Prior to the SDGs, we had the Millennium Development Goals, right, which were intended to be achieved by 2015. In those, there was no energy goal. There were about 8 goals that included things like equality, gender equality, water, sanitation, ending hunger. And when they were analyzing the MDGs and looking at what were the enablers or what were the barriers to achieving the MDGs, there was a lot of analysis in the UN that energy keeps coming up. You need energy to provide utilities with the ability to pump water from rivers, or you need energy for irrigation to achieve the hunger goal. You need energy for sanitation systems, basic electricity. And so there was a huge amount of political discussion that we need to have an explicit energy goal. In other words, the SDGs need to contain not just outcome goals, but enabler goals, means goals. Energy is one of them only, there are others as well, right? So we had SDG 7 that was created, but it was a very simple goal, right? Access to affordable, reliable, and modern energy services, but defined simply in terms of access to clean cooking, a binary check, right? Either you have it or you don't, access to electricity. That's it. And we're going to talk about how limited that is. So today, there's been progress. You'll see with electricity, the top row, a lot more progress than with cooking. We are, thanks to solar photovoltaic prices dropping so significantly, we have had in the last decade a run-up of off-grid systems powered by solar PV around the world. I'll talk about that later. As a result of which we've had a reduction in the number of people without access. Now we're somewhere around 750 to 770 million people without access. And then we have about 2.5 billion people, it's now 2.3 billion people, yeah, that's a really large number, who lack access to clean cooking. That means they burn solid fuels to cook food at home. And that number has not changed very fast, as I'll just show you. So there's a big difference between making progress on the cooking side versus electricity. So I'll start with cooking. Okay, so the number of people without access to clean cooking fuels is the brown in that bar. So as the global population has been increasing, even though we have seen a lot of policies that have extended access to clean fuels, that growth has not kept pace with population growth in poor countries. And so the number of people on solid fuel stoves has really not been decreasing very fast. So we're still at 2.3 billion people. And that's worrying. There are a lot of issues as a result of that I'll just get into. Where is this problem concentrated? Well, it's not surprising. You're looking for the lightest shade of purple. And this is primarily rural areas. Most cities in the world, people have access to clean energy. Not everybody, but a much larger share. This is showing you the percent of people in rural parts of all these countries. And you'll notice that Africa, barring a few countries in North Africa and South Africa, Botswana, Namibia, all the other countries have less than 10% of rural folks not using either charcoal or wood to burn for cooking. And then the other area that you have between 10 to 50% who still use solid fuels is India, China, South Asia, China, some parts of Central America, some parts of Southeast Asia. Why do we care about this? Well, this is a matter of public health and particularly women and children's health. So this graph is showing you on the y-axis, the percent of the population in countries that have access to clean cooking. And on the x-axis, you're seeing the number of female disability-adjusted life years lost per 1,000 people from household air pollution. So from inhaling the fumes from cooking, women and children are affected the most. And the dollar figure you're seeing next to each dot, which are countries in each of the regions, is the per capita income. So you're seeing that the richer countries have a high level of clean cooking access and low female disability-adjusted life years lost. On the right extreme, you're seeing very poor countries with people earning less than $5 per capita per day, with over 8,000 dailies per 1,000 people from household air pollution lost. So there's a clear relationship between overall economic development, but it's affecting women the most. Okay, so that's household air pollution. And the sad thing is, if you look at the progress of expanding utilities in overall development policies around the world, these are, each of the lines represents one utility like electricity or food, non-solid fuels, sanitation and water supply, and the percent of people who have access to that in these different regions of the world. You'll see the green line is the lowest in virtually all of the regions of the world. The progress and the absolute share of people with access to clean fuels for cooking is the lowest. And the next one is sanitation, the purple line. And both those affect women the most, actually. So we have a lot of progress with electricity provision, with providing people with a high number of average calories. But when it comes to sanitation and clean cooking, progress is the slowest. This is also a broad public health concern because of air pollution. So not only are the women and children affected in the homes where they're using solid fuels to cook, that air escapes into the ambient air and affects everybody. It's a public health hazard. But it's not the only source of air pollution. There are multiple sources, as you're seeing listed on the right. But the place where household cooking fuels dominate is in India, South Asia, and China. You can actually see it from remote sensing of particulate matter, that the blue color, which is pertaining to residential commercial energy use, has the strongest correlation to particulate matter air pollution that you see from the sky. And you can see that in different parts of the world, different things dominate. So in the US, it's power generation that's causing most of the particulate matter emissions. South Asia, China, it's coming from cooking fuel. So everyone is affected by this. So what's the solution? The solution is cleaner fuels. We generally think of three types of fuels, which we might talk in terms of different shades of clean, different degrees of cleanliness. So you have improved biomass stoves. I don't want to get into it, but essentially you're using the same fuel. You're just improving the thermodynamics and the quality of the burning so that you reduce air pollution. It has not worked very well for reasons I can't get into. It pretty much has been disavowed in the policy field and by academics. Liquid petroleum gas and electricity are the two main clean cooking solutions. Now, that's ironic because in the US, in the news, you've heard about gas being a dirty fuel and causing indoor air pollution, right? And that's a big issue, but you just have different standards in different parts of the world, depending upon your baseline, right? So LPG is kind of a standard of clean cooking fuels today in most parts of the world where you have this problem. Electric induction stoves, to me, are the future. Electrification of cooking also enables decarbonization in the future, has many advantages. So I'm a proponent of that, self-proclaimed, doing a lot of research in that area at the moment. But these are the solutions. And the idea is, how can we get more people to adopt these stoves? That's the challenge. And we just had limited success. And affordability is a problem. So let me give you one example of the reason why policies fail. This is in India. You've had a very aggressive program where the government has provided in a particular part of the country free stoves and one free cylinder with gas in it. And millions of households took this up. And it was seen as a big success story. And the question was, did people who acquired those stoves stick with them? So what you're seeing up here is a percentage of people in the green line, those who actually registered for this program, so who actually have a clean stove now. But below those dots and the orange line are showing you the refill sales, the number of people that actually refilled after that first cylinder finished, which is kind of in half a month or a month or so. Because the fuel prices are so high, people couldn't afford to continue to use the gas stove. And so they just went back to using the biomass stove, even though they had a clean stove. This phenomenon is known as fuel stacking, and it's widespread across the world. Everyone knows it. Everyone keeps, in rural areas, most people keep the cheapest stove available in case fuel gets too expensive. And they use the cheapest fuel, which tends to be the solid fuel, when the clean fuels are too expensive. So policies need to address the affordability of fuel, not just providing people with clean stoves, right? So that's really important. Of course, there's a lot more here. Like I said, I'm just giving you a broad overview. that policies have not been successful in this area. The other question that has come up in the last 2 decades is, well, what's the impact on climate change? If now we're planning to give everyone a clean cook stove, but we're calling it clean from an air pollution perspective, but it causes CO2 emissions. So what happens when you give everybody a clean cook stove, right? Now, again, I can't give you the research behind it, but the effect on emissions ends up being negligible. And in fact, even though you're burning a fossil fuel, due to the other types of emissions from solid fuels, from biomass, and due to the high efficiency of gas stoves, shifting to gas can actually reduce emissions. They're not zero because it's still a fossil fuel, but they're less than the global warming from biomass stoves, depending upon whether that biomass is extracted in a carbon neutral fashion or not. So that's pretty clear. But what about the reverse? If countries that have a lot of this energy poverty start to invest in clean energy, and that raises energy prices, then what I just showed you is going to keep happening. People will get a clean stove, but they won't use it because it's too expensive. So there's a risk that with climate policy, you will actually hurt the progress in alleviating clean energy poverty. So we did a study of this just to give you an example. These are the percentage of people with access to modern fuels over time. But if you implement a carbon price, you have less people that go off of it. So just imagine with time, in 2020, on the left side of the graph, with no carbon price, 70% of the population were on solid fuels. We expect with income growth that most people will get off of them by 2050. This is in South Asia. But if you implement a carbon price, right, then you're talking about energy prices that are much higher. People are going to stay on biomass stoves all the way till 2050. So that 70% number is likely to stay at 70% if you have higher carbon prices, or the equivalent of high energy prices due to climate policy. It doesn't have to be this way. You can have policies to protect the poor from those high prices, but in the absence of clear policies to prevent the poor from these energy costs, you need explicit action. Otherwise, it can be regressive in this case. So there is this interaction, right, between energy poverty and climate policy. But it's not fatal. There's plenty of institutions that are in these countries that can provide subsidies. They do provide subsidies, but that's a whole governance issue that we can't really get into. So to summarize, decades of research into 20 minutes, solid fuel use affects billions of people, especially women in poverty, and keeps them in poverty. The solutions are clear, but they're elusive. And they really require careful thinking about the policies that we need to keep people on these clean fuels. We expect fuel stacking will continue. So we have to keep that in mind and just encourage the greater use of these clean fuels, even if they retain the old ones. And finally, we have to think carefully about how we design climate policy. So that was cooking. Let's talk about electricity, which I think you've been engaging with a lot more in this class. There's been a lot more progress with electricity. About 100 million households today, largely since 2010, now use off-grid systems for electricity access. And that's something that's kind of a leapfrog, okay? It's not grid extensions that were the traditional form of providing energy access. So that sounds great. And you have an international market. Due to SDG 7, in part, there's been a funneling of funds from international donors. There have been private companies that have been coming in, selling solar systems, and it's seen as a big success. And so here, again, I'm showing you a similar graph to tell you where do you see the most progress. And you're looking for the brighter colors. So the red is where you have the least number of people with access to electricity. The yellow are the countries with the next least. And it's the same countries in Africa, right, in the yellow. So that's where the focus is in terms of the need for electricity access improvements. What are the solutions? There are a number of the solutions that we have. This is the most rudimentary, where you use your own human power to charge a battery, right? But there's beyond that, then there's a lantern where you have small little PV cell on a portable lantern, which is very useful. Women can take them out when they go in the evenings. It makes them safer for ablutions. You can charge a phone with it, perhaps. But lighting, the most fundamental need for electricity, can be satisfied. But that's it. Then you have a standalone solar home system, which includes a battery backup and a larger panel. And that, as you can see in the photograph, there are a few basic appliances that you can power with it. And then you may have an entire microgrid. So this is a village or a town that's powered by a little mini grid. But that grid is powered by a local supplier of photovoltaic, and that could be potentially scaled. But it may or may not be connected to a grid overall, right? So these are various kinds of solutions. Now, here's one of the issues with them. These tiers that you're seeing on the left, the World Bank and many researchers have tried to define tiers of access in order to try and categorize people into the level of service they have. So you're seeing in the second column on the left, the watts. That's the capacity of their connection to support electricity services. Keep in mind that all of these options here, if you get any one of these, you're checked off as having electricity access. Like if you get a solar lantern from D-Light, you're checked off as having electricity access. When all you can do is just use, maybe study in the dark and maybe charge your phone. But if you have something that's like a solar home system with a 50-watt panel, you could potentially have a fan, have a small TV screen, a radio, and lighting and phone charging. Most systems are in that range, right? When you get to 200 watts, 800 watts, and larger than that, now you're talking about mini grids, microgrids, or grid connection. But most of the systems that we're talking about are in the 50-watt or lower range. So you ask yourself, what are people getting from this success? How scalable are these systems? We actually don't know, but we don't have the data from the field to understand, is this a start of a path for these households, or is it just a temporary solution and they're going to be left with stuck at this level for time to come? So, for example, one of the things that we care about is heat stress, which is only going to be exacerbated with climate change, right? So if we're going to provide electricity connections to people, and if you can only get fans with larger than a 50-watt connection, and if in some situations fans are not enough because you're dealing with much higher temperatures and humidity, fans don't help you with humidity, you might need air conditioning. For air conditioning, you're jumping all the way up to at least 800 watts or more, right? So where are you able to support that kind of action, right? And in our research, we've tried to identify locations in the world. Now you're seeing the same locations pop up every time, right? We are trying to identify locations in the world where people they have temperatures that are uncomfortable, that require energy solutions for cooling, overlaid by population density, overlaid by income, like how rich are they? Can they afford air conditioners? And this is showing you places where you have those temperatures, you have high population density, and you cannot afford air conditioning. And that's a large number of people. In absolute numbers, they're concentrated again in South Asia and China, but in terms of percentage of population, it's those same countries in Africa. And that number, the mustard bar, the billions, exceeds the number of people who lack electricity and well exceeds the number of people who live in slums. So we're talking, 1 to 2 billion people here who are potentially facing heat stress. They have electricity connections, but either the supply is not good enough, or it's too expensive, or they just don't have a lot of money to afford an air conditioner. They could suffer heat stress. So we need to think about energy access in terms of these services, not just electricity connections, which means we have to think more broadly about the availability and affordability of appliances as well, and electricity connections that can support that level of service, right? So this is much more ambitious, right? But we're talking about fundamental comfort in the home, right? Energy justice ought to consider that, because heat stress can be fatal. We know it is fatal. So this is why I'm trying to get you to think about what should be the claims of energy justice, right? And we're only starting off with our energy access goals in SDG 7. So we need to shift from this thinking of binary solutions to multidimensional solutions. And there's many aspects in addition to just service expansion. Let me just give you a feel for it. So we want to we want to think about whether beyond lighting and cooling, there's other claims that can be made for energy services. So for example, should everyone have access to the internet in this day and age? But should you provide Wi-Fi to everybody? It's a very important form of democracies, right? The access to information and knowledge around the world to be able to participate as a political actor in an economy. It's a source of information as well as communication is really important. Mechanical power. Think about basic services we take for granted, like food processor. So the first thing people in households care about in terms of food is grinding grains to make flour, because that's, for poor people, the main form of nutrition is from grain consumption. And most women in poor countries grind their own grain. And when you have electricity, if you can afford a little mixer, you free up hours of your time. It's the same way you free up having to spend hours collecting firewood if you have a fuel connection at home. The same way you free up hours of collecting water if you have a water connection in your home. It's very similar with regards to mechanical power. So, and again, these benefit women. Then we talk about supply requirements, which I've already mentioned, right? We have to talk about the scalability of the supply, the affordability, and there's many other issues. A lot of people get electricity connections and supply is available for just 4 hours a day, right? For many reasons. I can get into it in the Q&A, but is that an adequate connection, right? Is that satisfying the claim of energy justice when you provide people with 4-hour connection? Especially if it's unpredictable. Predictability is a whole other dimension. I know I'm throwing a lot at you, but something will stick. And if something doesn't, ask me a question in the Q&A, but I really want to provide this broad overview to all of you. So I presented some challenges for cooking. I want to present you challenges for electricity access. I've already mentioned some in terms of what people need, right? But now I want to provide you some of the challenges from the perspective of the suppliers, from the perspective of finance in particular. So I keep saying things need to be affordable. How do you measure affordability? How do you know when your energy access is affordable? Well, what most companies today are doing when they provide electricity access, they're trying to beat the price of what people currently use, which is kerosene or paraffin, because they use kerosene lamps or paraffin candles, right? And that's not cheap, actually. It costs $5 to $8 a month. You may not have a sense for how much that is, but it doesn't matter. But if you're paying $5 or $8 a month on kerosene or paraffin wax, and someone comes in and says immediately, I'm going to give you a lantern, you don't have to deal with that, you pay about the same, just a little bit less, $7 a month, $4.50 a month, right? Everybody jumps on it, right? But actually, it costs a lot more than that to supply that lantern. And so you're paying that on a monthly basis, but you end up paying for it for a long time. Not only that, with such a small connection, you may, like I said, be only using it to charge your phone and to have some lighting. If you calculate what that works out to in terms of the costs of a unit of electricity, it's at least 5 times what you and I pay. $1 per kilowatt hour, maybe 2, maybe 3, maybe 4, in some cases, $10 a kilowatt hour. It sounds odd because you need the connection. There's a value to having an option to use electricity, but still, once you start to consume electricity from a few appliances, you start to ask yourself, is it fair that they're paying 5 times what we are paying, right? It is cheaper than what they otherwise would have. That's a good thing, but it still may limit their ability to enjoy the service. So you ask yourself, is that the right metric to use? Well, even if they're spending less than $1 per kilowatt hour, if their income is so low, they may be spending a high share of their income on just lighting or just on phone charging. And then you ask yourself, is that limiting their ability to spend on other services, on food, on getting around? Are they sacrificing their children's school education just to make sure that they have, the ability to make food at home or whatever? So that's the other metric. You're probably exposed to this as the primary metric for energy poverty in the US. It's energy burden, measured as energy expenditure over income. But we take for granted that people have all the services they want. It just costs a lot. And I've just demonstrated to you that most people don't get the services they want, which, by the way, I'm sure you've already learned is not the case in the US as well. A lot of people suffer energy poverty the way I'm describing it, even in the US. So that's an open question. What is affordable? Now, I said there's a lot of money flowing into these countries to provide energy access, which is a good thing. But let's see where the money is flowing. So these are not just for basic access, where these are clean energy investments. This could be going for grid decarbonization as well. But they're overall wind and solar investments in developing countries by the private sector and the public sector. And notice where the dots are in Africa, right? If you notice in the previous two graphs, the concentration of countries with the highest access problems were in the center. And those countries are not where you have any activity in terms of funds flowing, right? Look at the graphs below. The blue is among the developing countries, you have the upper middle income countries. That's where you have most of the money flowing. Then the green is the lower middle income countries. And the low income countries, the poorest countries, you don't have any investments. But that's where you have the greatest need for energy poverty solutions. Now, why is this the case? Because international money flows to markets that have some level of maturity, some capital markets, because people need to feel some kind of certainty about the rate, earning a rate of return, for example. So that top graph is showing you the flow of money to particular countries. The size of the bubble is the amount of capacity. And the graph below is the flows 4 years later. And you're seeing there's a lot more, like there's quite a rapid increase in clean energy investments, but it's going to the same countries, right? And those countries happen to be the higher income among the developing countries, like South Africa, for example, or Central America, right? Not much is happening in Central Africa, right? So you have a problem here with path dependency. You have very traditional metrics for creditworthiness, and those metrics, they don't exist in some of these countries, which doesn't mean people won't pay back the money. It just means that you have no way to assess the credibility of their finances. So we need a whole new thinking about financing and financing financial infrastructure to make the money flow to where it's needed the most, right? There's a lot of thinking about this right now. There's a strong awareness about it as well. And similarly, because of the fact that there's this risk premium associated with economies where there's not a lot of economic activity from international donors, you have high expected rates of return. So high costs of capital in the poorest countries. So look at Africa's average rate of return required by private investors, close to 12%, but in Europe and the US, it's 4 to 5%. The mature, well-known markets, right? And in particular countries, you'll find it being seven times higher. Like the cost of capital can be over 20% in certain select countries, right? So this is making the energy even less affordable, right? So the photovoltaic panel, the wholesale cost may be cheap, but you add the cost of capital of finance and it blows it up completely. So we have a lot of challenges facing us in scaling up energy access to the level that we need. I also want to accentuate this phenomenon I mentioned about the sustainability over the long run. There was a study done where people monitored the usage of new electricity connections over time. So these lines are showing you how much is electricity consumption growing among people who just got a connection, months after their connection. So up to 10 years after their connection, you're seeing that line. The dotted line is the urban and the solid line. I'm sorry, the green is the urban and the brown is the rural. And the dotted lines are the range of uncertainty. But the point is, after 10 years, you have people who got a connection not consuming more than 70 units per kilowatt hour. I mean, that's very, very low. You know, it's barely 3 times what they had when they first connected. And you may ask, is it because the electricity was unaffordable? Is it because they're just poor people? They can't afford more appliances, right? There's a question here. We can't put all of the focus on energy policy. If we want people to enjoy energy services, like I said earlier, we need their incomes to grow to afford appliances. So Electricity access is one enabler of human development, but it has to be accompanied by overall livelihood development, income growth, other services, and that may not be happening in poor countries. So I'm throwing on something new here. I'm saying not only do we need to expand how we think about energy access, we need to think about development policy and the coordination between energy access policies and other development policies to a greater extent so that we can derive the benefits of energy access. Across Africa, on average, the per capita energy consumption has been flat since 1990. Now, how many of you would have guessed that? Right? Since 1990, 30 years, the average per capita energy use has virtually stayed flat. This surprised me completely when we wrote this paper in 2021. Even then, I didn't know it. Why? Because population growth is outpacing energy growth. So you do have growth in energy systems and infrastructure. It's not keeping pace with population growth. So the average per capita energy use staying flat. So this is what I mean. If that's the case, how do you expect broader development to happen, right? Even if you're giving people connections, right? Daunting, I know, I'm throwing a lot at you. It is daunting, but it's the real world. We got to appreciate it, right? So to summarize now, I summarized cooking with electricity access. The key takeaways, we need to expand what we mean beyond binary connections. We have to think about services, right? Which includes the demand side, what people need, income growth, appliances, financing, and quality of supply. Solar PV is great, but I presented a lot of issues with you. It is a leapfrogging opportunity, right? But we need to really exploit it better. I think that we need much more regulation of the off-grid market to consider these issues, to standardize quality, to ensure scalability, affordability. All of our service is regulated. Our suppliers have a standard of obligation. We have a fixed rate that we all pay, right? Why should people getting access today from new systems pay much higher, right? There's an equity issue there. And then we need income generation and we need a rethinking of international finance. Okay, so that's a lot. And I'm only getting started. So that was that was energy access. Okay, now I want to broaden to talk about, okay, what about those indirect uses of energy for providing healthcare, for providing food? How do we even think about that? Okay, and this is new research, okay, in the last 5 to 7 years. And I'm going to just pick a little nugget of it because there's a lot here. So let me just walk through it. If you look broadly, now we're stepping out to the country level, okay? Not to the household level. And we're looking at the relationship between average countries' energy use and various human development indicators. And we generally find this very sharp increase in human development at low levels of energy use as you grow, and very little gains in human development when you're at high levels of energy. Because this is really important. What it's saying is you can make really strong increments in human development with very small increments of energy growth at low levels of development. At the top end, you're talking about this whole energy sufficiency issue and excess. And I'm not talking about that. I'm focusing on the left-hand side. There's something to be said about how much growth in human development we're seeing on average associated with small increments in energy growth per capita. Now, contrast this with the traditional view of just growing GDP, where you see a much more linear relationship, right, between energy per capita use and average GDP per capita, which would suggest that, you got to grow energy all the way up to, 100 gigajoules per capita to get beyond $10,000 per capita. But there's a lot of questions about how much human development you have at that income level, right? Whereas if you're down here at 25 gigajoules per capita, according to this relationship, small increments can be associated with a lot of human development index improvements, that is, life expectancy and education improvements. And those may be valuable for poverty eradication. So if that's a priority, then perhaps you have to think about where your services are going. Where are you developing your energy services, right? Where are your target power plants being built? Where are you providing electricity connections? to whom are you providing those connections? It can have a different impact on human development depending upon where you target those services. So that's the equity question within countries, right? But it also is a broader question that how much energy do you need for poverty eradication? It's not a linear relationship. So you can't just say, oh, okay, I think we need this much if you want to get this rich, right? Because human development is more complex than that. Okay, so that's fine. We want to figure out and understand how much energy we need, but that doesn't mean this is a global justice problem. National governments have their own priorities. They're trying to figure out how to raise energy use, but nobody's talked about that as a global justice problem. But now with climate change, all of a sudden, there's an imperative that all countries, poor or rich, have to invest in clean energy, right? Which is more expensive, as I've just pointed out. So now we're going to all of a sudden increase the cost of energy if all poor countries have to decarbonize their economies completely. So then you ask yourself, how much of a burden is that on poverty eradication? Or conversely, if poor countries are going to not be part of the solution because they're poor and they grow energy for poverty eradication, those claims may be legitimate, but how much of an impact is that on climate change? How many emissions do you need for poor people to grow out of poverty? So, there's been, again, decades of research on this question. And the idea is, how can we find a way to distribute the burdens of climate mitigation that respect poor countries' capabilities as well as their intrinsic priority to increase standards of living and to eradicate poverty? And that's a unique situation for poor countries. What's the relationship here between poverty eradication and climate change? So that's the nugget I want to talk about in terms of national energy requirements that are potentially going to increase the costs of mitigating climate, or conversely, increase the cost of improving living standards if they are to decarbonize immediately. And I think it's nice to see the Sustainable Development Goals as illustrating this relationship between well-being and environmental constraints. I like this graph. It kind of organizes the SDGs into goals that are focused on well-being in the center, goals that are environmental on the red on the outside, and they're mediated by kind of means indicators, goals around the built environment that deliver energy services to achieve well-being. So one nugget from this we can extract, which is, if we're ending poverty, what impact does that have on the other SDG of combating climate change? And the connection between these two is energy. Land is the other connection, but I'm not going to talk about that. The reason why we care about this connection is because energy is central to both, as I've mentioned, right? For climate, we understand that. And so we're trying to understand the relationship between poverty and climate change through energy use. In other words, put it simply, how much of the poor's emissions do we have to decarbonize, right? Is it a big issue or not? And we never knew how to answer this question until 5 to 10 years ago. One of the reasons we didn't know how to answer this question is that we didn't know how to define poverty in the first place, because thinking of it just as an income threshold didn't tell us a lot about energy requirements, because we don't know what poverty really is in terms of $2 a day, $1 a day, $4 a day. What services are you getting for that amount of money? And so, I was part of an effort to try and define the material basis of poverty, thinking about actual physical services that people get, and translating that to energy use is much more straightforward, because it allows you to understand the services people are getting on the one hand and how much energy you use on the other hand. So I'm going to skip a little bit of this because I want to. How many minutes can I keep going for the online community? Okay. Okay. Well, yes. So unfortunately, I can't summarize the rest of the presentation. I'll be going for 10 minutes. So if you want to tune back in, it's just be about 10 minutes at most. So the idea was, how do we define consumption that's essential? a set of basket of goods and services that we think are necessary to achieve well-being. They're not sufficient. And so there was a lot of work that I did in coming up with a theoretical approach to defining these indicators, using theory, using empirical data, using expert elicitation. And at the end goal, we came up with a basket of things that everybody in a modern society would agree we should all have. And let me point out some less than obvious things. There's physical well-being, but there's social well-being, which is really important, which also raises material requirements. And so I've already mentioned cooling, but if you think about social well-being and connecting to the rest of society, we may be interested in appliances, a mobility infrastructure that extends to everybody, education and healthcare that extends to everybody. And we have to include those and their energy requirements in defining the energy needs for eradicating poverty. So the first step was, what does poverty mean in the first place in terms of material requirements? Because that's how you can then translate it to energy. And so we did that, and you can go to my website. We have an interactive map that shows you the percent of people in 2015 that lacked access to each of these dimensions in all the countries. And that was a huge effort and a starting point for, even before thinking about energy, for understanding poverty in material terms, in terms of what goods and services do people have or lack. And by the way, you can look at this later. I'll circulate my presentation. The maps on the right-hand side are showing you different levels of income poverty. And what we found is the deprivations on average in these living standards almost always tends to be higher than most poverty thresholds that are used in income terms. So income poverty, even in its most aggressive form, tends to underestimate the services people need for a decent life. The point I want to make here is, since you're talking about energy, you have to think not just about direct services, but those direct services require infrastructure, and that infrastructure to be constructed also requires energy. So there's this hierarchy that you can derive of material requirements from which we calculate energy use. And on that basis, this was the voila answer that we came up with. This is summarizing by region some interesting data. So let me walk through this, because that's the last thing I want to share with you. So you're seeing by region, the green line is the actual national energy consumption in those regions on average, okay? So the North America on the leftmost side, Pacific, Asia, Western Europe, former Soviet Union, Eastern Europe, China, et cetera, Latin America, South Africa, South Asia. Obviously, it's decreasing. That's the green line, is the total national demand. The dotted black line is what we calculate to be the energy requirements to hypothetically provide everybody with decent living standards. That's like the aspiration level for energy use. And the brown is the amount of energy today that's actually delivering decent living standards. So the first thing to think about is the difference between the brown and the green, right? Of course, in affluent societies, you expect there's a lot of energy use for quality of life above basic living standards. But even in South Asia and Africa, you see the gap between the brown and the black line, right? The large gaps in decent living standards for people, even though the total energy consumption is above the black dotted line. That is, the total amount of energy that's being supplied every year is enough, in theory, to provide everyone with decent living standards. But of course, there's energy inequality in all countries. So this points to the energy inequities within countries, right? That also is important, not just overall growth in energy use. We need that. In African countries, we need significant growth to get to that black dotted line, especially with future population growth. But the more equality or the more equity we have within countries in development, the less the overall requirements for energy growth. But that's the key point here. So in terms of global justice, this is bringing up the issue that poverty eradication itself doesn't seem to be a big stumbling block for climate mitigation, because the share of emissions globally that are required for achieving decent living standards is actually not tremendous. It's about a quarter of current annual energy use. So that points against there being a significant conflict. But at the same time, for certain parts of the world, it's a serious burden. And these poor countries in Africa will invest in natural gas and lock in if they don't get international assistance to switch to solar and wind. And now at least we have some quantification of the extent of that dependence in different parts of the world, which was the goal of this. So some of the takeaways: energy growth serves affluence more than poverty eradication globally. Energy needs for poverty eradication compared to national energy demand are actually modest in most regions, except for sub-Saharan Africa, where you will need unprecedented growth to get people to achieve their decent living standards by the time the SDGs come about, or even just after that. To achieve the SDGs, we need unprecedented growth, along with very transformative shifts towards equitable development, so that energy access is growing the way we were talking about it, in ways that will serve the most important needs for human development. So we need to think about global justice, global climate justice in terms of energy in particular, because these countries need to invest in energy in order to raise living standards, and they will. And we have to, on the one hand, figure out ways where we can create sort of international cooperation arrangements for that to happen through international finance. But we also need to make sure we encourage equitable development within poor countries that have to grow. So I'm going to stop there and ask you if you have any questions. I'm happy to discuss any of the topics earlier that I brought up. Anything goes. Thank you. What's that? Bye, everyone. Thank you. Shall I stop sharing?